assuming that one of them has CP, TCP?
I'm not going to tell you that. I will tell you that you're probably going to have to prove triangles are congruent. Obviously, if that's your goal, then especially if I know I'm proving triangles are congruent, my last step is going to have a reason that is one of the 5 acronyms. Like some of you wrote other things, definition of congruent triangles. That, in order to do that, you'd have to prove every pair of sides and every pair of angles. So you're going to use the shortcuts to prove triangles are congruent. And then if you're trying to prove parts of the triangles are congruent, you're going to use the shortcut to prove the triangles are congruent. And then you're going to use CPCTC to get to that last step. I think there's 3 questions like this where you just get given a picture and you have to say whether or not they're congruent. Okay. And I thought these were not hard. And I think maybe only 4 of you got all of them right, if that. Okay. Number 1, what's not marked already. So this is what you want to train yourself to see. What am I looking at? Obviously, you want to identify what's already marked, but then what's not marked already is what? The reflexive side here is a shared side. So that would be one side. And then you've got the one arc that matches the one arc. That's a pair of angles. And then you've got your double arc that matches the double arc. That's a second pair of angles. So that's 2 A's and an S, right? But there are 2 theorems with an angle, angle, and a side. There's angle, angle, side, or there's angle, side, angle. Hold, please. If it's the included side, which is this case, then it's angle, side, angle. That's the easiest way to do it. Some of you put angle, angle, side, and you could have gotten there if you then proved that the third angles would have also been congruent. But if that was a step in a proof, you'd have to add third angles theorem for that. So you didn't need to do that. I would have given it to you, but you didn't need to do it, okay? And I would have expected that to have been marked to show that that would have been the third angles. So the correct answer is angle, side, angle there. Okay, 2, you're given 1 pair of angles, 1 pair of sides, and what's not already marked that you have? The reflexive side. So I've got an angle and 2 sides. It is not the included angle, which means this would be an ASS. And is that a thing? No. These are not congruent. And some of you said there was a right angle there. Unless it's marked or in the directions it's given to you that is perpendicular, you cannot assume that that is a right angle. Okay? So that one was not congruent. 3, you've got 1 pair of angles given, 1 pair of sides, and then what's there that it's not already marked? The vertical angles. So I have 2 angles and the side between them, which means this is angle, side, angle. Again, if you use the third angles theorem, you could have gotten angle, angle, side, but I wouldn't have even gone to that step. Okay, and then 4, you've got 1 pair of sides marked as congruent. What else?
You could have angle, side, angle with alternate interior angles.
So if these are parallel, and I use this transversal first, this and this would be alternate interior. Or you could go the other way and use this one and this one as alternate interior. That would have been angle, angle, side if you use that. But the easy thing that's not marked yet is what? The vertical angles. So these would also be congruent, okay? So I probably would have used one of the alternate interior angles and then the vertical angles. And depending on which alternate interior you use, this could have been angle, side, angle, or this could have been angle, angle, side. So sometimes there's more than one. Some of you put side, side, side. Actually, quite a few of you put side, side, side. The only thing I know is congruent are those 2 segments. No other side was marked. And for side, 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 you'd have to know all 3 sides. Mars. Sorry, go. You got to say it.
How do we know to use angle, side, angle, the side? How do we know to use angle, angle, side?
So if you have 2 angles, like 2 pairs of angles, right? And then the side that connects those 2 angles is the one that you know. That's angle, side, angle. It's the side that connects the 2, so it's the included side. If it is not the side that connects the 2 angles, then it's angle, angle, side. Kala.
Wouldn't angle, angle, side be easier because you could just say that those 2 were congruent to the other 2 in one step? These are alternate interior.
If you're trying to do the least amount of sides, sure. But I think vertical angles is easier to spot than alternate interior angles. Yeah. All right, then you had your proofs. Some okay, some not okay. This question, if I go straight to the proof, is trying to prove triangles are congruent, right? So my very last statement is going to be that triangle is equal to that triangle, and my reason better be one of my 5 acronyms, Okay. I know from this that BD bisects, so if I wrote the given out, BD bisects angle ABC and angle A equals angle C. So I can mark the A and the C, and that would be my given. What do you see from your diagram without needing to know anything else?
That BD is reflexive.
The BD side is shared by both, so BD equals BD, and that's reflexive. All right, so then I already have one pair of angles and I have one pair of sides, which means no side, 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 right? Like I can already start to eliminate some of these things. None of that has anything about a right angle. I can eliminate hypotenuse leg. So start to plan for stuff like that. Kala. You mean angle, right?
Yeah.
So because it says it bisects this angle. So here's my angle and here's the bisector, which means it is cut into two congruent angles. So I can say angle ABD is congruent to angle CBD, and that's the definition of, you can either write just bisector or you can write angle bisector. I would have taken either one. It is specifically an angle bisector. So now I've got two angles and a side is the one that connects the two angles. Is that the included side? No, so this would be angle, angle, side. Triangle ABD is congruent to triangle CBD. Angle, angle, side. Mars.
What if I prove that segment AB and segment CB are congruent?
How would you have proven that?
The CBT.
Oh, you use the big triangle and then the base angles?
Yeah.
No, CPC.
No, because the AB and CB are congruent because of the bisector.
So the bisector cuts the angle in half. It has nothing to do with the sides. It doesn't.
It bisects it.
Correct. You could, if you wanted to, use the big triangle, and you could have used these angles and the base angles converse to show that the out two sides are congruent, and then you could have used side angle side. That's another way to do that, but I think that's more complicated than it needs to be. All right, 6, again, write the 2-column proof. This time we're trying to prove that AE equals DE. So every single other proof that we've done in this chapter is to prove the triangles are congruent, and then yesterday we add in those parts. So if I go to parts of two triangles, that last step is going to be my CPCTC. So I'm going to first work to prove the triangles are congruent, and I know the most information about this top one and this bottom one. So I would use the given information just from the diagram because there's no additional information, which is that AC equals BD, angle A, actually angle CAD, I have to use 3 letters, CAD is congruent to angle BDE. That's all given. Then what piece of information is in my diagram that I haven't stated yet? So because E is shared by 4 angles actually, I got to use 3 letters, but AEC is congruent to BED, and that's the vertical angles theorem. And now I've got angle, angle, side. So my triangles are congruent. ACE is congruent to triangle DBE, and that's angle, angle, side. And then, if 2 triangles are congruent, all of their corresponding parts are congruent, which means AE equals DE, CPCTC. They could go a step further and say, like, prove that E is the midpoint of there, and I could go to the next step, and I could say it would be the definition of midpoint. So that's the only other variation you would see. But most of them, when we've gotten to segments or angles at the end, we've used CPCTC to prove it. All right, and then the last one, it says E is the midpoint, so that's my given. E is the midpoint of TP and MR. So what? Yep.
So then you have to prove that, ME and ER are congruent.
So ME equals ER and
And TE equals.
good. TE equals EP, and that's the definition of a midpoint. Some of you put bisector. Bisector wasn't given to you. The word midpoint was given to you. And then what's there that's not part of what's just given from the diagram? The vertical angles. So angle TEM is congruent to angle PER, vertical angles theorem. So then the triangles are congruent. EMT is congruent to triangle EPR. Good. Side angle side. And then angle M is congruent to angle R. CPCTC. Yeah.
I use like a different angle. Like I use MTE as my angle.
How though?
Because
Like after you prove they're congruent?
no.
Oh, you have because you don't know that yet.
Okay.
Yeah.
So it's gonna be
Like there's no alternate interior because there's no parallel lines there, so you couldn't use anything else. Yep. Again, if you haven't already exported from ClassKick, you need to do so you save this because again, that's good practice. On your to-do list for this evening is the Chapter 5 review. This is going to be collected. This is homework. This is due tomorrow. I changed it, right? It is due tomorrow. It goes through the sections. So in 5.1, this was where we're classifying by the sides and the angles. So obviously you need to know those terms, scalene, equilateral, isosceles, right? Or right, obtuse, acute, and equiangular. We learned about all the angles adding up to 180. We learned about the exterior angle like this one being the sum of the non-adjacent or remote interior. All that stuff came from 5.1. And that the complement or that the two acute angles in a right triangle add up to 90. That kind of stuff came from there. Yeah.
We're turning in homework.
Yeah. What?
You get those going
This is going to be due to Canvas tomorrow morning at 8 a.m. This is to be turned in. Okay. Then 5.2 was just general congruent polygons. So like if two polygons are congruent, then all of their sides are corresponding sides are congruent and corresponding angles are congruent. So there's a question on your quiz where you just had to match up the sides and the angles. That should be an easy question. 5.3 is where you got into your first acronym, which was side angle side. That is all we had on the quiz. So now you're adding in 4 more. That's when it makes it a little bit more complicated because it's not only just one, okay? 5.4 was your equilateral and isosceles triangle. This is your base angles theorem, your converse to your base angles theorem. And then if they're equilateral, they're equiangular. And if they're equiangular, they're equilateral. Those 4 things, like it was 2 corollaries and 2 theorems. And then 5.5 was side, side, side. 5.6 was angle, side, angle, and angle, angle, side. 5.7, which is what we did yesterday, was the CPCTC. Again, this is to be completed and turned in to Canvas by 8 a.m. tomorrow morning. Okay, this will be a graded review. Clear, you need a little nudge in the direction of reviewing.